Very good. So as you go through, we've got first quadrant. X and Y intercepts are at 3 for X, 6 for Y. Are you okay with that? Again, all we're doing is cover and solve. Okay? So here's 6, and I label it 0, 6, 3, 0. Connect the dots. La 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 la. Did it go through the origin? No. So what's 0 plus 0? 0. Is that smaller than 6? Yeah. So it's moving inward. Now here's a real tough one. What's the ordered pair here? 0, 1.
Oh, wait.
No. You say that. I tried. What are the 3 ordered pairs now you have to test? 1, 1, and then 3. So you've got your ordered pairs. 0, 0, 3, 0, and 0, 6. We substitute into our objective. And then, and you get 0, 9, and negative 6. Where's the maximum? 9. The maximum value is at 9. The maximum where it occurs is at the ordered pair. Remember, the value is the maximum. Where it occurs is the ordered pair. Yes, ma'am.
Or is there another way to do it?
It is, if you are intrinsically aware of how systems work and how signs work with all of the inequality stuff, you could figure some of the ordered pair stuff out. But as things get more and more complicated, you have to believe me that you're going to want to graph them. Okay? This first one you could have kind of not seen if you intrinsically understand how things work. But as you get into the more complicated ones where you've got 3 or 4, when you've got 4 of them with like 2 or 3 different inequalities built in, you're going to want to do it all. Because that way you know which direction everything's going, so you can get lost real quick. So graphing is your best friend. Trust me. That's why we've been working on it. Well, let's keep practicing. All right, keep practicing. Okay? Yes, sir.
Is the answer like the actual?
Where I think it asks to find the maximum. I think it said find the maximum and the minimum value. Did it say maximum minimum value, I believe? So your maximum minimum value is 9. The minimum value is negative 6. I'm saying that's the value. I'm planting the idea of what does this mean. So as we get to the word problem, because then this could mean 3 coffee pots and no spoons. This could mean no coffee pots and 6 spoons. Okay?
Yep.
Thanks for agreeing.
Yep.
I think she knows what she's agreeing to, but whatever. All right. Constraints, objective. Once again, as you go into this one, excuse me, you have x values that are less than 3, x, y intercepts at 3, y intercept at 3, and an x-intercept at negative 4.5. Everybody okay with that? So this one looks like I'm going to have to do a little bit more. So I'm just going to set the whole thing up. All right. First one, I know that the largest intercept is going to be at that negative 4.5 for x. So if I want to do that one first, it's fine. I also see I've got a whole bunch of stuff going around 3s, so that's not a big deal. So if I go out to negative 4.5, I'm going to plot that there. I'm going to label it. The labeling it then would be at negative 4.5, 0. Okay. The y-intercept would have been then at 3. So that's 0, 3, and I connect them. Okay? Within that one, did it go through the origin? No. So I use that as my test point. 2 times 0 minus 3 times 0 is 0. Is 0 bigger than negative 9? Yes. So I cover the truth, so it's pointing downward. Okay? I do this again with x and y's at 3. Hey, there's an intersection. Where do those two intersect? In this case, we didn't have to algebra that one. Okay? It's nice when it works like that. Okay? We didn't have to algebra it. So I have one intersection point at 0, 3. Again, does that line go through the origin? No. So what is 0 plus 0? 0. Is 0 bigger than 3? No. So it's false now at this side, which means it's true moving outward. So right now we're in this region. So far so good? Now lastly is the x is less than 3, so that's a vertical line through 3. So I should probably extend this one a little bit that way. It's nice when you have a smartboard, you can kind of move stuff as you want. And then it's vertical through 3, which means I hit this one there. Which means I have to figure out which of those which of the other two inequalities or equations did that run into? Well, it ran into that one. That's how I'm going to find the ordered pair. Bless you. Okay. First of all, I had to shade it to the left because it's moving. It says it's less than. So we've got this region in here we're working with. I just have to find that ordered pair up on that line. I know what the x-coordinate is because it's vertical. As you go vertical, you're constantly staying at 3 in this case. So the ordered pair here is 3, comma, well, whatever 3 works out to be in this equation. So 2 times 3 minus 3y is negative 9. What's 2 times 3? 6. Move it over to the negative 9, you get negative 15. You guys agree?
Yeah.
What's negative 15 divided by negative 3? There you go. There's your other ordered pair. See what I meant by let's not worry about finding only ordered pairs with some of those crummier looking equations from recently? Because they're not as clean. They're not set up to make it clean. Alright? Hold it. Now, from there, we have a bounded region again. I keep saying bounded region. Do our regions need to be bounded? No, they don't, because you could have an open-ended region, which means if it's opening upward, you'd have no top, no ceiling, no maximum. Same thing with the floor. There's no bottom to it. You could have no minimum. It's completely, totally possible, depending upon the problem itself. Okay. So in this case, we have the 3 ordered pairs to test. We have 0, 3, 3, 0, and 3, 5. So constraint function, 2 times 0 plus 4 times 3, 12. 2 times 3 plus 4 times 0, 6. Thank you, sir. And then last but not least, 2 times 3 plus 4 times 5, which is what, 26? Where's your maximum? Where's your minimum? 26. Yeah. Remember, what we're doing is we're just working through our our ordered pairs, and we're substituting them into the actual what do you call it? Objective function. Okay.
Keep going. Nothing.
She's waiting for a skill check.
No, we don't do it there.
Sorry, I forgot that. Everybody. What was the last thing we had to do? Was it 7? Take a deep breath. You're fine. You're all right. It's not like we're doing anything difficult. ish. like this, x is between 0 and 60, what does that mean? You're bound between 0 and 60. When you're between 0 and 45, you're 0 and 45. This makes right away a rectangle.
Can you put the thing so I can get which
We're done.
like the one in the middle of the screen? Can you move that or no? Which number? Yeah.
I don't have power in my house.
Wait, right now? That's what you want to do.
I'll go. I have power. I hate you, bro.
He had to brush his teeth with a bottle of water.
This is Russ's teeth. So, when you add, so those were
What do you think?
this guy. So what I did was when I did that, with 1, 1, that was these two equations, I believe. So what I said was x is 3y minus 2. I used substitution real quick. When I did that, I think, is it this one? Yeah. So these are the two, I think it was x minus 4y. I moved the y over, and I substituted x into here. And I got y was 1. And then I threw 1 back into here. No, this wasn't this one, it was the other one. It was this one. And then I threw 1 back into here, 3 times 1 minus 2. So I did it was another one of the system states, but in this case I just used substitution. So that it can get messy. Just slow it down, slow it down. Alright. Yeah, when you do that first one, ladies and gentlemen, hey guys, just a little top tip. You know that you have x-intercepts at 0 and 60, y-intercepts at 0 and 45, and then you look at the next one, 5 goes into this, what, 64, I think, for 5x, and this is 70. So your idea is you still want to look at all your intercepts to figure out where things running across from one another. As you plot that one through, it looks a lot messier than it really winds up being. Because you've got you say 0, I'll put 60 here. And if I say 0 and 45, what's this ordered pair right away? 60 and 45. Okay. 5 goes to 420, was at 80, it's 84. I said that, right? It's 84?
Yeah.
So 84 is the x, which means it's beyond this, about here. And then 6 goes into what, 70, I think?
Yep.
So that's up here. I connect them going through. Means here's your x coordinate for the one, here's the y coordinate for the other. Okay? So as you go through it, you know which one is which. This is 60, comma something. This is something, comma 45. That bounded region becomes within here. That region winds up in here, so you get 1, 2, 3, 4, 5 points. Even though it looked weird, see how fast that one actually is?
Yep.
A lot of them are written like that. Horizontal and verticals as you go through. Just a little FYI as you look at it. Oh, and I meant to give you guys your quizzes back. Sorry.